This is Algebra 2 with Trig 1C.1c. Today we are going to solve quadratics by using factoring. So to solve quadratics, we're going to use what's called the zero product property. You probably learned this in middle school. You definitely learned it in Algebra 1. If you have two expressions, these are called expressions right here. If you have two expressions, we'll call it A and B, and they have a product of 0. They multiplied to be 0. Something has to automatically happen. Either the A term was 0 or the B term was 0. So A equals 0 or B equals 0. So what we're going to do with quadratics, we're going to take our first factor and set it equal to 0, and our second factor and equal it to 0. That's why we call it the zero product property. One of those has to equal 0. So we're going to come to our first question. We're going to try to find what's called the x-intercepts. So essentially you're putting this into intercept form. And we put it into our parentheses. We know our first set, we're working on FOIL backwards, right? What multiplies to be x squared? It has to be x and x. What are two numbers that have to make 15? Very common one would be 3 and 5. Are they two apart from each other? Can they make the number 2? Okay, if you had a -5 and a +3, they would make the number 2. So -5 plus 3 makes -2, so we factored it correctly. Now we do our zero product property. So we set each factor to 0. We subtract 3 to the other side to get -3. We add 5 to the other side to get +5. And there we have it. If we were looking for intercepts, we would have an intercept at -3 and an x-intercept at +5. Those would be your x-intercepts on your graph. Remember, you can always use your graphing calculator, and you could go to calculate to determine what the zeros of the function are. And that would be a good way to check your work. Okay, to check it. Not to do it. We're going to do it using our factoring format. But that can be a process that you can use to check your work. Another word that we can use is called roots. What are the roots of the function, or roots of this equation? Notice what's different about this one. It's equal to 35. It doesn't equal 0. Whenever you have a B term, listen to this carefully. Whenever you have a B term, your quadratic has to equal 0. This doesn't equal 0. Is it broken? No, we can just make it equal 0. So we move the 35 across, and you have x squared plus 2x minus 35. You need to bring everything to the same side of the equal sign. If you have a B term, you have to bring everything to the same side of the equal sign so it equals 0. You cannot take the square root if you have a B term. Now we can try to factor it. That's 7 and 5. That multiplies to be 35. You want a positive number, so you want -5 plus 7 to give you a +2. If you're not sure about the positives and negatives, we need to talk about that. Now we're going to use the zero product property. So you set them both equal to 0. I would like to see that. Set them equal to 0. If you want to show your work to say minus 7, that's fine. You don't have to. You can just say x is negative 7. You can add the 5, but you at least would say x equals 5. So those would be your two roots of the equation. So we've talked about x-intercepts, and we factored and did the zero product property. We have roots, and we factored and we did the zero product property. Next, we're going to talk about zeros. The zero of the function. Still the same thing. The x-intercepts of the graph in intercept form are P and Q. Those are the x-intercepts. Because the function's value is 0, when x minus p equals 0, and when x minus q equals 0, p and q are called the zeros of the function. So another set of directions, still doing the same thing, is called find the zeros of the function. We're going to write it in intercept form. And then we're going to do the zero product property. Find the zeros. So this is often written with a y. Well, we want to know when this equation is going to equal 0. So we plug a 0 in for the y. And that should be factorable. So you want two numbers that multiply to be x squared. Two numbers that multiply to be 28. Well, you might get carried away and think 2 and 14. But 2 and 14 can't get us to 3. 2 and 14 might get us to 16. Might get us to 12. But can't get us there. But 7 and 4. 4 and 7. The larger number has to be positive. So there you factored it. You just got to think your way through what the possible values are, or you can make your table to help you create that we've talked about before. So then we're going to do our zero product property. So I'd like you to write that out. Then if you would like to jump and go straight to the 4 and straight to the negative 7, I'm okay with that. Use some brain power there. Those would be your zeros of the function. If you were to plug the 4 back into the equation, 4 squared plus 3 times 4 minus 28, 16 plus 12 minus 28, that's 28 minus 28, that is 0. That checked. Same thing would happen with negative 7. Just be sure you square the negative 7 to get 49. Okay, on this side, what do you see? You think about that for a moment. We're looking for zeros. So it's 0 equals x squared minus 4x plus 4. This is a perfect square trinomial. You might recognize that. So there's a little shortcut to it. But you probably just, it's nice simple numbers, and you think, well, what multiplies to be x? What multiplies to be 4? How do we get negative 4? They both have to be negative. And then we can do our zero product property. And I'd say there's only one answer to that. You don't need to circle them both. There's only one answer. The answer is 2. On a graph, that's going to look like this, where you're crossing here at 0, 4, and you're crossing your x-axis at 2, 0. In terms of a graph, that's what those numbers mean. On the flip side, solutions to a quadratic equation can be referred to as x-intercepts. Those are solutions to a quadratic, or x-intercepts. We can also call those zeros and roots. So on your final exam, you might have the question, which word does not belong? X-intercepts, y-intercepts, zeros, or roots. X-intercepts, zeros, and roots all mean the same thing. So they all belong. Y-intercepts are not like these. So that would be the term that would be not following the rest. Is not like the others. Okay, here's a story problem. With the story problem, let's pause the video. You've got to try the story problem. You know how to do this math. So pause the video, read through this, and then I'll walk you through how to finish it up. Give it a try. All right, let's take a look. You have a rectangular vegetable garden. We all understand what a rectangle is. So let's draw that rectangular vegetable garden. The dimensions measure 10 feet on one side, 15 feet on the other. We can all do that. We're going to add a certain amount on one side. Let's call it x. We're going to add that same amount to the other side. We'll call that x. When we add that additional part, we are making the rectangle bigger. We want this rectangle to be twice as big. You want to double the area. For you to double the area, you need to know what the current area is. You're going to double the area by adding the same distance x to the length and the width. So I added the x and I added the x. My current area is 150. I want to double that. So my one dimension here is x plus 10. Don't call it 10x. It's definitely not 10x. It's x and it's 10. X plus 10. This is x plus 15. And we want that to be 2 times double the 150. So you have to watch this word. Is it going to be double? Is it going to be triple? Is it going to be half? That value is what you're multiplying to your current area. So we'll come through and factor this, or actually FOIL this. It is factored. We'll FOIL this. X and x makes x squared. 15 and 10 make 25. 10 and 15 make 150. So I FOILed that together. And 2 times 150 is 300. So what do we do from here? This has a b term we talked about. We don't want to, or if we have a b term, we need it to equal 0. So we're going to move the 300 to this other side. Now it equals 0. So it equals 0, just like all the other problems we've done. So we'll factor this apart. It can seem a little tricky to factor a big number like that apart. Let's think about some numbers we know. This is 150. So let's think about it as 15 for a moment. What multiplies to be 15? 5 and 3 makes 15. But I need another 0 to show up. So if you say 3 and 50, that makes 150. 5 and 30, that makes 150. So we know the first terms multiply to be x squared. 5 and 30 multiplies to be 150. Because 5 times 3 is 15 and the extra 0. So we need a positive 30 and a negative 5 for it to add together to be 25. So we factored it apart. And then we can set these equal to 0 using the zero product property. Which answer do you think is more appropriate? Can we add a negative 30 onto the side of a rectangle? That doesn't make sense. So we are going to add 5 more feet onto both sides of our rectangle. So we're going to have 5 plus 10 to be 15 and 5 plus 15 to be 20 because we're adding 5 to the 15, we're adding 5 to the 10. We come down here to question 8. We pretty much do the same thing. We have the area of a box that equals 16. So I know that a rectangle is length times width. So that means I'm going to have length and width. Doesn't matter which is which. It's not W, I guess. It would still be X, 'cause my other one was X, all right? It's going to equal 16. This looks different. What do you think we do here? We would need to distribute. The only way to get the 16 involved is if we can get rid of these parentheses. So we're going to distribute to say 3x squared plus 2x. That still equals 16. And we wanted to bring our 16 across because we have a b value. We need to make it equal to 0. So we can factor this. One way we've talked about factoring is to say 3 times 16. That's negative 48. 3 times 16. And it has to add to be 2. What multiplies to be negative 48 and adds to be 2? Negative 6 and 8. If you know your multiples, you'll come up with that. Otherwise, you can complete the full chart. 3x squared minus 6x plus 8x minus 16 equals 0. Put your two factors in the middle of your A and C. They're going to add together to make 2x, so they have to be negative 6x and positive 8x. Circle your first two pairs. You get 3x can be factored out of that with your GCF. You'd be left with x minus 2. Bring down your sign. Factor out what you can. You'd be left with x minus 2. Your parentheses are exactly the same. That's factor by grouping. Some call it decomposition. 3x plus 8 and x minus 2. You can use the zero product property, subtract the 8, divide by 3. Add the two. Our side length can't be negative, so that's ruled out. The only answer is 2. So we've got our last question we're going to work on. Revenue question. Remember that that is price times the number of items. So we have our revenue price is $30, and the price is changing by $1, and the number of items was 1,500, and that's going to decrease by 25. So that's our equation that helps support this. An internet provider sells internet service for $30 a month to 1,500 people. Each $1 increase in the price, the number of customers decrease by 25. So we need to figure out how much should the company charge in order to maximize. Well, charge was their money. So we're working on 30 plus 1x. Well, what we're going to do is type that into our calculator. We have 30 plus 1x, no need to say 1, and 1,500 minus 25x. We're subtracting 25 every time we increase the price by 1. So we go to table, and we can scroll through here. I'll go back to 0. That's how much the beginning profit was at $30 for 1,500. When we increase the price by $1 and we lose 25, we still make more money. And we keep making more money all the way until you see the price start to decrease, and it decreases right here. Then it starts to go back down. So our X is 15. So to maximize our profit, we're going to be at $45. We plug our 15 into our equation to get 45. What's the maximum revenue? Well, real quick, it's the Y value. It's right there. You could go back up to your equation and say 30 plus 1x times 1,500 minus 25x. So that is 45 times 1,500 minus. This is 375. So we subtract, if we're subtracting 400, that would be 1,100, but 25 less is going to be 1,125. And I'm expecting that to come out to be 50,625. Let's go ahead and test that theory. So that was 45 times 1125 was the 50,625. That's the maximum value we would get if we decrease the price 15 times. Or that's actually increasing the price 15 times. So 15 more dollars, and we would decrease the number of people by 375.